What is going on? It is February 6th, 2022. February is humming along, and I have gotten deep into my brain studies. Okay, so I think this entire month is just going to be devoted to studying the brain and the different anatomical structures of the brain, and to some extent the peripheral nervous system and autonomous nervous system, but autonomous nervous system. But I really want to now delve right into the brain and consciousness structures. It's been a long interest of mine anyway, besides my eternal life search. And I did a little bit of that before, and it took a detour, but now I'm going back into it again because I think it deserves elucidation and it deserves understanding. What are we going to talk about today? I wanted to start with the primary motor cortex because that is in the prefrontal lobe. That is typically, it seems, where people start when they talk about the brain. And the primary motor cortex is basically, it's this gyrus here. I think it's called the precentral gyrus, right? That's the anatomical term, but the actual functional term in terms of the how stuff what actually happens here, or what executive functions in the brain are propagated to the body. It's responsible for pretty much all skilled work, anything that you do with your hands, anything that you do with your body at all, right? Any motion that you undertake, any action that you undertake really occurs in this precentral gyrus or primary motor cortex. And also the primary motor cortex is next to the supplementary motor area, but the secondary cortex next to it. I'll get that clear as to the details later. But this primary motor cortex controls, as you can see in this diagram, it controls all the different extremities, right? And their sensory, it's organized in a specific way, and actually in an interesting way, because there are neurons which have specific destinations, sensory neurons and motor neurons, which correspond to these areas. And if there's any damage or blockage of blood supply to these areas, or to areas that are co-located along these regions, right, then the region will stop functioning. So basically, there's an artery behind your brain or within your brain called the anterior cerebral artery that supplies the blood to your brain. And I think in horror movies, when your brain explodes, that's what where the blood starts popping out from. But anyway, that blood supply needs to travel through this area. And if it's blocked at any point, which in some cases, in the cases of some types of embolism and things like that, which we haven't really got into, like a blockage here will cause your lips to be paralyzed. The blockage here will cause your feet, your shoulders, your elbows, your trunks to be paralyzed. So basically, and you can see kind of a pattern as this goes superior to your body all the way to your inferior regions of your body, from top to bottom. So this is a very important area. Obviously, many parts of your brain are important, but this allows you to do things, right? So the other interesting thing is, where is this located? This primary motor cortex is located near the central cut in your brain that divides your frontal lobe from your parietal lobe. Okay, and this central, and that's why it's called a precentral, I think it's precentral gyrus, the anatomical piece of tissue, but because this is the central fissure, and then this is your central sulcus, and then this is the actual gyrus. The interesting thing is the way it's typically described, I've seen, is in this form called the sensory motor homunculus. And the reason now you see these images, the reason why this sensory homunculus first of all, what is it? So the sensory homunculus is a mapping of the different parts of your somatic sensory cortex to, and your motor cortex, to different parts of your body, right? So you saw a side view where it said feet, head, etc., blah blah blah, lips, face. In this frontal view of the brain, right? This frontal cut, you have your you have your face mappings, you have your hand mappings, your teeth, etc., your arms, and notice, right, that the hand section and the face section are extremely large here. And if you look at this picture here, this is actually a funny thing, but these are extremely large because they're the magnitude of the parts of the body that are described by this homunculus, so to speak, sensory motor homunculus, indicate the amount of fine motor control that your brain has dedicated to these parts. So your lips and your tongue have a ton of fine motor control. Your hands have a ton of fine motor control. Your legs have, barely any relative to your tongue and lips, and I guess your head and your face. Yeah, because think about it. You need to do a lot of manipulation with your hands. You need to do a lot of manipulation with your mouth and your tongue, right? Your tongue can move in all kinds of directions, so you have a lot of sensory motor neurons that are dedicated to interacting and acting your tongue, right? And I guess other parts of your body, your ears as well. That's interesting to me. You probably have a lot of sensory neurons here, but I don't think there's many motor neurons on your ears. I don't know if some of this is exaggerated for the purposes of, parody. And here's your masked version of your sensory motor homunculus. Anyway, so basically you have, and I guess the division sort of makes sense. You have your motor homunculus and you have your sensory homunculus. So I guess both together are the sensory motor homunculus, but your sensory, that makes sense because your sensory homunculus has ears that are larger. Your motor homunculus has basically no ears at all because, I can't move my ears. I guess some people have more motor neurons connected to the ears, which is genetically determined, so they can voluntarily move the tops of their ears. Whatever the case, this is kind of the subdivisions, and then here's the other view that's very popular, the sensory motor homunculus. Again, another frontal view that kind of maps the different external parts, like more finely or more in more discrete units of the sensory motor cortex and the premotor. This is the sensory homunculus, right? So yeah, we have to get it clear what's the sensory. So the motor cortex has a map to different parts of the brain, and the sensory cortex has a map to different parts of the primary motor cortex and primary sensory cortex. Okay, so that was a lot of terms, and hopefully at some point I'll get to trim down this talk a little bit and sound more cogent. It will probably take a little while, but there's a lot to learn here, so bear with me, and I'll leave you with this last picture, which has actually everything all together. It has the frontal part of the frontal cut of the brain, and it has the sagittal cut of the brain, or sagittal view of the brain, which shows your primary and somatosensory motor cortexes, which they're co-located, they're next to each other, right? So that kind of makes sense. Where you sense stuff and where you cause action to stuff should be located next to each other, which is located right adjacent to this central fissure, which is medial to these two gyri. Okay, sensory motor cortex and primary motor cortex. Okay, that's enough for today. I'll see you